As part of our footprinting process, it's often handy to understand the IP addresses behind some of the names. MX records, CNAME records, and so forth. Well, what kind of tools can we use to extract that information? That's what we're going to cover in this nugget. If this is our target that we're trying to learn more about, and they've got some public-facing web servers, they're going to have some DNS entries about those servers. Also, if this company is receiving email messages, it's very likely they're using some type of an email server. Whether it's in-house or a third party on the web, that information will also be in DNS. So as part of the discovery and reconnaissance that you and I are doing as we footprint this company, we can go ahead and use DNS to gather that additional information. Now, the types of information that we can get from DNS would include the various record types. So if we did a Google search for DNS list of record types and pressed enter, in my current search, I've got a top hit here for Wikipedia, which I'm going to grab. And this is giving us a list of various DNS record types. So if we scroll down a little bit, here's some very common ones. An A record, which represents a 32-bit IPv4 address. A quad A record, which is an IPv6 record, which is a 128-bit IPv6 address. Down here near the bottom of this page, we have a canonical name record, which is an alias of one name to another. And as we continue scrolling down, there's a couple more I just want to point out. Here we have an NS, a name server record, that we can use to identify the authoritative name server for a domain. And here we have an MX record, which equates to effectively an email server or a relay agent. So you and I, as part of our footprinting, can query DNS and discover information regarding the IP addresses behind those record types, and then use that as part of our documentation. And the next question might be, well, what's a great tool to use to collect that information? Well, a tool that exists on most operating systems is a command line utility called NSLOOKUP, which can make the queries into DNS and provide us the answers. So if we're sitting here on this computer and we're running NSLOOKUP, we're using NSLOOKUP based on the commands and connectivity from this device. But what if we want to do NSLOOKUP and we want to do it from a different perspective? For example, maybe we want to launch it from a device here out on the internet. There's also web-based tools from lots of different companies where we can connect via HTTP or HTTPS over to their site and then use their graphical user interface and automate many of those same requests and doing it from their perspective. Because internally, we may be using an internal DNS server, maybe internal or on our DMZ. So it's just handy to be aware of additional options so we can take advantage of those if we want to. So here at our Kali Linux box, let's open up a shell and let's type in NSLOOKUP space, and then we'll put in the domain that we want to get information on. In our case, we're going to use www.hackthisSite.org and press enter. So using the tool NSLOOKUP on Kali Linux, it's showing us our default DNS server that we're currently using, 8888, which is a DNS server from Google. And it's showing us non-authoritative answers. That's because the Google DNS server is not the direct DNS server that has those A records. So in DNS, there's a recursive process that allows us to go to the actual domain server that is authoritative, or we can get that cached information from another DNS server that already has that in memory. And it's showing us a bunch of IP addresses, 136, 138, 135, 139, 137. So that's showing us there's multiple IP addresses, and those IP addresses also could be connected to load balancers. And then those load balancers could be further distributing the request across multiple servers behind each of those IP addresses. Now, this is showing us the A records, the IPv4 addresses. If we did the same command from Windows, it might show us by default the A records and the quad A, the IPv6 records. And regardless of the defaults, we can be very specific in how you and I ask for information. So besides the NSLOOKUP in non-interactive mode, which is what we just did, we put NSLOOKUP space in a domain name, we could also use NSLOOKUP in interactive mode. It works like this. We type in NSLOOKUP and press enter, and it's just sitting there waiting for us to do something else. So the giveaway here is that we have this prompt that's asking us or waiting for us to be interactive with this utility called NSLOOKUP. So let's specify that we want to look for a certain type of record. To do that, we're going to use the command set type, which implies we want to set the type of record that we want to retrieve, an equal sign, and then the type of record. So bringing back just for a moment our list of record types, if we wanted to find quad A records, IPv6 information in DNS regarding a domain, we could simply set the type to AAAA. So let's do that. So here in interactive mode, we'll set the type to AAAA and press enter. And now we can do our query. So to do the query, we're simply going to put in www.hackthisSite.org, press enter, and now it's going to return to us the quad A records from DNS regarding hackthisSite.org. And if you want to learn more about IPv6 fundamentals, there's an entire course at CVT Nuggets on IPv6. And probably the first, I don't know, 4 or 5 nuggets of that course would be enough to give you a familiarity and a comfort level with how IPv6 operates and how it works. And I would recommend those first several nuggets as a bare minimum if you're new to IPv6. If we wanted to get DNS information regarding the mail servers and the mail transfer agents associated with hackthisite.org, we could do a set type $MX for mail exchange and press enter. And then I'll just hit the up arrow key a few times and we'll do the request for hackthisite.org once again. And I'm going to do that one more time, but I'm going to go ahead and take off the www. So just hackthisite.org and press enter. There we go. So here are all the email servers or message transfer agents associated with hackthisite.org. And based on the MX records, it would appear that they're using Google. And is it possible for you and I to get more information about any one of those mail exchange record servers? And the answer is yes. To do that, we could go ahead and, for example, set our type back to a record and then do a search for one of these. I'm just going to copy paste the first one here. So I'll highlight it, copy it, come back down here, right click and do a paste and press enter. And that gives us the IP mapping for that MX record, which is this guy right here. Now, because that's part of Google, that may not be that valuable to us for that specific target. But if it was one of their own MX records, one of their own servers, that would be more interesting because it's part of the target space we're trying to attack. Either way, we can document that as part of our footprinting, again, using DNS tools to discover that information. And also, whether you're doing this on Windows or whether you're doing it on a Linux platform, the commands are going to be very similar, even if the output varies just a little bit. Also, if we wanted to use a different DNS server, currently my computer, this Linux box, is using 8888 because that's the current DNS server. So NSLOOKUP is defaulting to that. But if we wanted to use a different DNS server, we could tell NSLOOKUP in interactive mode to use that. For example, we could say server space, and I'm going to use 192.168.1.212. Now, that IP address, if we look at our topology just for a moment, that is the IP address of a 2012 server in our lab environment. It has DNS services running, but there's no entries in it. However, because that 2012 server also is using 8888 as a DNS resource, which is out on the internet from Google, that 2012 server can still go out and make queries on behalf of us. So this is just an example of specifying a different DNS server that NSLOOKUP can use as opposed to the default DNS server that's configured on your computer. So this implies that we're now going to be using .212 as our DNS server as part of the NSLOOKUP interactive mode, and we're using port 53. That would be UDP port 53 for DNS request, which is the default port. So now let's set the record type back to A. And let's hit the up arrow key and do a search once again for hackthisite.org. And this time, that request is going to 212. And then our server at .212 is either going out to the internet to make that request or potentially has it cached and is delivering that back to the client. Another great option is to use web-based tools. So let's do a search for NSLOOKUP web-based tools, press enter. And one of them right here is network-tools.com/NSLOOKUP. Let's go ahead and use that one. So from here, if we want to search hackthisite.org, we could put that information in. For the query type, we could specify the type of record we're looking for, an A record, or a CNAME record, or a mail exchange record, etc. Or we could say, give us everything, any type of record regarding hackthisite.org. And by default, it's specifying a DNS server that it's going to use. And then we simply click on Go. So if we scroll down just a little bit, so here it's showing us a start of authority record. So the name server that is the authoritative name server, or at least one of them for that zone, is ns1.hackthisite.org. Perhaps on a site that was less careful, they would have a real username for the individual responsible for this zone. As we scroll down a little bit, we have a list of name servers that have information about that zone, or at least know how to reach the authoritative name server. We have several mail exchange records right here. And as we scroll down a little bit further, we have some A records and some quad A records. And if we wanted to isolate or filter out the responses, we could say, okay, please just show us the quad A records. Click on Go. And now here it's showing us the full list of quad A records, which is great. So this listing should represent the same list that we got from the NSLOOKUP from the command line that we demonstrated earlier for IPv6 addresses with that domain. I hope this has been informative for you, and I'd like to thank you for viewing.